Hello Algebra 2. This is the Day 5 notes, graphing review, and finding inverses. Our essential question is, can I use my knowledge of parent graphs to graph logarithmic functions? And can I find the inverse of an exponential function and logarithmic function? So some review first from Day 2 notes. Considering the parent function of a logarithmic function, complete the following questions. They want you to write the equation, go ahead and graph the translated function, and find our characteristics: domain, range, increasing, decreasing, the x and y intercept, and end behavior. So the first step is remembering how to find the parent function. We haven't graphed these in a few days. So remember, it can be found using a table. And what we're going to do for the table is convert it to exponential, because we understand how equations with exponential equations are found, but we're still learning how logarithmic function equations work. So I'm going to first convert our log function to exponential. So our log one is y equals log base 4 of x. I can write the equivalent equation by converting it to exponential. So I just take the base of the log 4, and then this is our power. 4 to the y is equal to x. And these two equations are equivalent. So I can use this to help me graph any log function. Now we're used to inputting x's to find y, but we can do the reverse. So I'm going to use this new equation to help me. And if I input 1 for y, I will get 4. If I input 0 for y, I will get 1. If I input 2 for y, I'll get 4 squared, which would be 16. And if I inputted -1 into y, I had 4 to the -1, and that would be 1/4. And now we can use these to graph. I can plot these points and graph them so I can see what the parent function looks like. So I can plot 4, 1, 1, 0. 16 and 2 is pretty far off, but that'll help me draw my line and my function. And 1/4 -1 is 8 in here, and then that helps you remember where my asymptote is. So remember, for my log function, the parent functions, our asymptotes are x equals 0. Okay. So there's our parent graph. We can use this to help us write our equation and to graph it. So remember, our logarithmic parent graph can be translated using a, h, and k, just like all our other functions we've done this year. And when we have 2 units to the left, we're going to be plugging in a -2 for h, and 1 unit down we'll plug a -1 in for k. So our equation is y equals, and they didn't say it's going to reflect or anything, so our a is going to be 1. And then we'll plug in -2 because it's moving to the left, and then -1 because it's moving down 1. And then we'll clean this up, and our equation will be x plus 2, because x minus a -2 is positive 2, and there's our equation. Okay, now they want us to graph this translated function. So I'm going to use my parent graph to help me. First, it's moving to the left 2, So I'm going to move my asymptote to the left too. So here it's x equals 0. So this one's going to be x equals 2. So I'm going to go ahead, negative 2, because it's moving to the left. So I'm going to go ahead and graph that. And then I'm going to take my points. So 4, 1 on my parent graph here. It's got to do 2 translations. Got to move left 2 and down 1. So 4, 1 will move left 2 and down 1. So that'll become 2, 0. And then the parent graph point of 1, 0 will move left 2 and down 1. And then our 1/4, negative 1, will move left 2 and down 1. And that'll help us graph it. Okay, we can also use our calculator to check. So let's go ahead and pull that up and check to make sure we know how to graph with the calculator so we can check it. Okay, so the hardest thing about putting them in when it comes to the translated is remembering that what part with using the change of base. So we have that function of log of base 4 of x plus 2. So when I input it, remember the calculator only has log of 10. So I have to change it to log of x plus 2 divided by log 4. And then subtract the 1. Okay, so that's how you're going to see. Here's your table. You remember you pull up your table by hitting second, graph to see the table, and then graph to see your graph. Okay, and we did a good job using transformations. I'm going to go ahead and write that down here, and so that you know how to put it in the calculator. So this would be easy to make a mistake on. So we want to make sure you're understanding this with the transformations and then using the calculator to check. Okay, now I want you to just review these words we've been talking about all year, the characteristics of a graph. Go ahead and fill these in and then bring it back to check. Okay, so please check your answers, and then if you have any questions, if you're confused on some of these, I want you to write question marks next to the side here. So when we get to class, I can visually see what questions you have. So let's say that the increasing is confusing to you. You would put a question mark here. And then say the y-intercept, how to find that, which there's 2 ways to find that. One is using the table in the calculator, or by plugging in 0 for x and solving for y. But if you have all 7 question marks, that's fine. We just want to clear up any confusions you have. So you go ahead and decide which ones you will put, and then to pause the video and do that so we can help you next class. Okay, the rest of the notes are going to be talking about how to find the inverse of a function and reviewing graphing those. And remember our steps for finding an inverse. No matter what function it is, the first step is we're going to switch x and y. Then we're going to solve for y. Last step, number 3, we're going to rewrite using the inverse notation. So that could be seen if they don't tell you, label it as f of x or g of x, then you can just use y to the negative 1. If they had labeled the function as f of x, then you would write f of negative 1 of x, and so on. So if it was originally a g function, you would say g of negative 1 of x. Alright, so our first one, number 1, is y equals 4 of x. So my first step, I'm going to switch x and y. And the only thing that moves is x and y. Everything else stays in the same place. So not a lot of parts to this problem equation. So this x moves here to y. That y moves to that x. And now you have to solve for y. So we learned solving last class, and the only way to get to a variable in the exponent is to convert it to the logarithmic equation. And to do that, we're going to, first step would be to write down log, then our base of 4, then our x becomes the of part of my log, and the answer is the exponent, and that's what we're trying to get to. We're trying to get to the y. That only required one step. We already got the y isolated, so there's our inverse. So my last step is rewrite using the inverse notation. So I'm just going to add my -1 to show that it's the inverse. Alright, for number 2, again, our first step is to switch x and y. So the only thing that moves again is the x and y. The e is going to stay there, that +3 is going to stay there. So when I switch x and y, it'll be x equals e to the y plus 3. Alright, again, the only way to get to an exponent, a variable in the exponent, is to switch to log. So our first step for switching to log is log, write down log. Now write the base, in this case it's base e, and now the x is the of part, and what the equation's equal to is our original exponent, so y plus 3. So again, when you convert from exponential to log, first step is you write down log, then you write the base, then you move this to this side, and the y plus 3 is equal. Alright, so the log base e, we have to remember that e is the number 2.71828. It occurs naturally, and it is we also use that in our standard calculator. So we have that in our calculator, and it's called the natural log, and on the calculator it's ln. So log base e is ln. So it's this button here. Okay. Also, while we're here, remember the E button is in two places. The first one is if you hit second and divide there's an E, and the other place is a second above the ln, so second and ln. And when you hit this version, it pops up with the exponent. So you can just type in your exponent. Okay, so knowing this, we're going to change that to the ln, because in a little bit we're going to be graphing these. So log e is equal to ln, the natural logarithm, so that gets substituted. Now we have to solve for y. To get y by itself, we have to subtract 3. And y is equal to the ln of x minus 3. So the last step is rewriting with the inverse notation, and so that would be then adding the -1. Okay, we have two more to do. First one, we're going to remember when we're finding the inverse, we're going to switch x and y. So we have x equals ln of y plus 2. Now, anytime you have the y inside our of part, we have to convert to exponential to find that y. So go ahead and pause the video and try that. So it's helpful to do that in reverse when you're converting. So the natural log, we change the log e, then convert. So we have e to the x equals the y plus 2. Then to get y by itself, we'll have to subtract 2 and then rewrite using the inverse notation. Alright, let's try one more. So the first step is switching x and y. Then we solve for y by converting, and then use the inverse notation. Lastly, remember that the graphs of function and its inverse are related to each other by reflecting over the y equals x line.